Hello class and welcome back to Historical Geology, and today I want to look at activity 1.6 and show you 9 samples for you to identify following the instructions here from the lab for this week, and then we'll be filling out this table here, so there's only 9. Now the first sample, sample number 1, is this sample here, and just to give you an idea of sort of scale, it's these little structures are in the order of maybe 5-6 centimeters in length. You can see this top one back over here. So what we're looking at in this figure, we're looking at these laminations. You see there's a layer here, and then there's a structure between there, another layer, and they seem to be in this curved pattern. You can see them over here, making these kind of mound-like structures. And if we look a little bit more carefully in here, you can see these kind of curvy structures in there. You can really see the fine laminations in here. If we kind of look at the sides here, yeah, you can definitely see those mound-like structures. So for this sample, this is sample number 1. We want to say that it's, give me the common name, and then we've talked about these have a range from the Archean. In fact, some of the oldest ones found in the world are from Australia. They're about 3.5 billion years old. And so you can probably figure out what this one is. And so when you're looking through there, for the phylum, don't have a phylum, but we have a domain for these. So you want to say that it's a domain bacteria. We don't really have a class for these either, but you could say that it's a more specific bacteria would be that these are cyanobacteria, right? So instead of phylum, put bacteria for domain, and then instead of class, we'll say cyanobacteria. And these are in a limestone. I tested this with acid at Fizz. So these are replacements. So you'd say the type of phosphorylation would be replacement. And then what would be the telltale sign? Well, you can see it right here. So that's what you want to write in your table here for sample number 1. All right, so now we'll look at sample number 2. Are these kind of walnut size, and they're on the order of about maybe 3.5 centimeters here at the largest. And again, we're seeing that concentric growth on these, very similar to the previous sample, but instead of growing columns or big mounds, these are forming smaller. And so this is something that I showed you in the previous video. I don't have it in the lab, but for this sample number 2, the common name is an oncolite, right? So I'm doing this together with you, an oncolite. And more specifically, these are also believed to be formed by cyanobacteria. So you would say the kingdom or domain, in this case, bacteria, and then for class, you want to say a cyanobacteria, photosynthetic cyanobacteria. In fact, these samples are from the Chambliss Formation over near Chambliss in the Mojave Desert, so out kind of the central to eastern part of the Mojave Desert. And they're Cambrian in age, and they're just right near here, there's another unit called the Latham Shale just below this that has trilobites. And I'll show you some of those trilobites next week because I have some of those from the same area, from the unit that's just a little bit older than this. But these are Cambrian in age. So again, they're doing photosynthesis. Again, no symmetry for these. Don't worry about the symmetry. And their ages, well, some of these are found in Death Valley in units that are actually Precambrian, going back maybe about 600 million years. So I would say Precambrian to present, because cyanobacteria is still around today. And then the preservation method here, these are in limestone as well. And you would say it's a replacement. And what's a telltale sign? We got these concentric laminations or growth, right? So we're doing that for sample number 2. All right, so let's look at sample number 3. So sample number 3, I have a little vial of these, and you can see that they're almost like these little grains of wheat. Their diameter is in the order of about maybe 5 millimeters, maybe 6 millimeters at the largest. So they're small. Let's see if we can zoom in a little bit more on these. Yeah, so they're kind of like little grains here, and they have this kind of rolly appearance. And so this For sample number 3, you could probably figure out what this is. It is a type of Foraminifera, so I'll tell you that now, so you can look up what that is, and then you can figure out what in this case we don't have a phylum. You just want to call it kingdom Protista for these, right? Kingdom Protista, and then figure out the name of this one here. And there's 2 types of these on the protozoan or Foraminifera identification page. And you want to figure out whether it's one or the other. And for these, actually, they both look pretty similar. So it's really hard to tell. I found these in a drawer at the college here. You can see kind of the long, almost striations on this. So I know they're late Paleozoic. So pick one of the 2 there. All right. So that's sample number 3. So sample number 4. Well, you can see one right there. These are from the White Mountains over east of the Sierra Nevada, near up above Big Pine and Bishop, California, kind of east of there. And the key thing about this one, kind of the telltale sign, is that this has a double wall. And just to give you a clue here, these are Cambrian in age. They're sessile organisms, and they're related, although they're probably a little bit different, but they're related to sponges. So look in the sponges and see if you can figure out what this guy is. But the telltale sign here is that double wall structure for this guy here. So that's sample number 4. And then and for the symmetry, I guess you could say maybe it has a radial symmetry, although most of these organisms did not have much symmetry, but this one seems to have somewhat of a symmetry. But the key thing, again, that double wall structure. So sample number 5, if we zoom out for this one, because he's kind of big. So sample number 5 is an interesting fossil. It measures over probably maybe 10 centimeters in length. So it's relatively large. It has these kind of knobs or nubs that kind of stick out on the sides there. And it's in a limestone, so it's a replacement, right? Whatever this was, it's no longer this soft tissue. Now it's this harder limestone, but it has these little nubs. And it is in the phylum Porifera. So see if you can find what this one is and fill out the details for the lab on sample number 5. Sample number 5 there. And again, you could always pause the video to take a closer look at this or a longer look at this. All right, let's go to sample 6. So this one you can clearly say that there's been some replacement, but maybe even some recrystallization where we're losing some of the intricate features of the surface of this fossil. But the key thing about this one, or this fossil, is that we have this sort of chain link, and it is some sort of coral. And if we look at the size of the coral here, we see that there is this tabula that seems to be more prevalent here. There are some septa here, but there's some tabula. But the key thing is this kind of linking or chain link. That'd be kind of the telltale sign. But it does have some tabula. So it's probably a tabulate coral. You can see another one there. So now your job is to figure out what type of tabulate coral here. And this is more of that, again, that chain link type of tabulate coral. All right, so that was sample number 6. Let's look at sample number 7. So this is another type of coral, but the key thing about this coral, again, there's replacement here. The key thing is that this has the individual theca here, or where the polyp lived, is that it has that 6-fold radial symmetry. In fact, this one looks really good. 6-fold radial symmetry. The other key thing about this fossil is that the theca, or these little cups, protrude out. See how they stick out from the fossil? So that's going to help you identify this coral. All right, so you can look at this sample here. This is sample number 7. Sample number 7. All right, sample number 8 is this guy here. And this guy's kind of unusual. It forms a kind of a star-shaped pattern. In fact, it is in your lab manual for a bryozoan. So this is a type of bryozoan, and it forms kind of that star-shaped pattern. And that's kind of the telltale sign for this type of bryozoan. And again, would probably be replacement, or it's still calcium carbonate, but you can see it's a little bit more grainy than the original fossil would be. So again, this is some sort of bryozoan. See if you can figure out which one using the identification for bryozoans, and also the geologic range for this type of bryozoan. And the last one is also a bryozoan. And this bryozoan here is actually, we'll call it number 9. And in fact, let's look at both of these together. So for bryozoans, we don't really have classes, but in the text, I talk about how there's the branching twig variety. There's the Archimedes variety. There was a Fenestella variety. So based on those, you can answer that. Give me the phylum, which is Ectoprocta for these. But then based on what you see here, so here's the bryozoan we're looking at right here. This is probably more of a branching one, right? And so for class, you can say branching twig. And for this one, you can remember for this one, it should be like this in life. And so you can tell me what type of pattern that is, or what category it would fit on there. So again, look at your lab on page 18, and I talk about the different types of categories for bryozoans. All right, well, that's it for the fossils. You should be able to identify these pretty straightforward. All right, again, we'll see you next time.